Welcome to Copilot Podcasts. A framework named after a turtle might be the most serious idea in AI safety right now. Not a firewall, not a kill switch, a turtle. Today, we're breaking down the rizikos, which translates to the turtle card, a structured concept for keeping humans and AI systems in check through 5 distinct layers of safeguards. By the end of this episode, you'll understand what each of those layers actually does, why slow and stable progression is a feature and not a bug, and how this connects to the biggest global conversations happening right now about AI risk. My guest today knows this territory deeply, so let's get right into it. Walk me through what we're actually talking about when we say the turtle card.
So the rizikos, the turtle card, is a structured framework that organizes the relationship between humans and AI systems into 5 distinct layers. And the name itself is doing a lot of work. The turtle is slow, deliberate, protected by its shell. That's the whole philosophy baked into the concept from the start.
Okay, so before we get into the layers themselves, give me the 30-second version of why we even need something like this. Why layers at all?
Because a single layer of defense is never enough. That's not just a philosophical position, it's what the research keeps showing. The International AI Safety Report 2026, which was led by Turing Award winner Yoshua Bengio and authored by over 100 AI experts backed by more than 30 countries, explicitly states that layering multiple approaches offers more robust risk management. That's the core insight.
Over 30 countries. That's a massive coalition.
It's the largest global collaboration on AI safety to date, according to the report itself. And what they found is that real-world evidence for several AI risks is growing, and capabilities are improving rapidly but unevenly. So the urgency is real. You can't just bolt on a safety feature at the end and call it done.
There's actually a really vivid analogy I came across in the research. Someone compared deploying AI without proper safety layers to building a skyscraper and skipping the fire escapes.
That's exactly right. And the architectural guidance from industry leaders like Red Hat and AWS reinforces this. Security has to be integrated across multiple layers, not treated as a single perimeter. The turtle card takes that same logic and applies it specifically to the human-AI relationship.
All right, so let's actually walk through the 5 layers. Start with the first one, the human layer.
The human layer is the foundation. It's the recognition that there has to be a human presence, human judgment, and human accountability at the core of any AI system. This isn't just about having a human press a button somewhere in the process. It's about embedding human values, human oversight, and human responsibility into the architecture itself.
And that connects to something I found really striking in the search results. Pope Leo XIV's encyclical from May 2026, Magnifica Humanitas, which literally means magnificent humanity. He wrote that technology is never neutral because it takes on the characteristics of those who devise, finance, regulate, and use it.
That's a profound framing. And it's not coming from a tech company or a policy paper, it's coming from a moral authority making the case that the human layer isn't optional. The encyclical calls for people to build for the common good and to remain human. That's essentially what the human layer in the turtle card is demanding structurally.
It's interesting that a papal document and an AI safety framework are landing on the same principle from completely different directions.
That convergence is actually meaningful. When you see the same conclusion reached through engineering, ethics, and theology, it suggests the principle is robust. The human layer isn't a niche concern, it's a consensus.
Okay, so layer 2, the AI rhythmic layer. This one sounds almost poetic. What does rhythm have to do with AI safety?
It's one of the more counterintuitive layers, but it's grounded in real research. The idea is that AI systems should operate in rhythms that are legible and predictable to humans, not erratic, not opaque, not constantly surprising. Rhythm here means patterned, timed, consistent behavior.
And there's actual science behind this, right? Not just a metaphor?
Absolutely. Researchers at Ghent University and Vrije Universiteit Brussels published work on dynamic systems approaches to modeling human-machine rhythm interaction. Their computational model, which simulates how the cerebellum processes rhythm, demonstrated that AI can accurately perceive and adapt to rhythmic patterns within the human perceptible range. The key finding is that rhythm synchronization between humans and machines is achievable, and it produces behavior closely aligned with human interaction.
Wait, so they're literally modeling the cerebellum to understand how AI and humans can sync up rhythmically?
Yes, using what's called a reservoir computing framework. And separately, researchers from NYU and UCLA published work in Frontiers on what they call cyborg synchrony, integrating human physiology into AI music systems. They found that physiological synchrony between people relates to social bonding, and they proposed AI systems that attune to each user's unique physiological rhythms. The point is that rhythm isn't decorative, it's a mechanism for trust and connection.
So the AI rhythmic layer is essentially saying if AI behaves in ways that feel rhythmically coherent to humans, we're more likely to trust it and catch it when something goes wrong.
Exactly. Unpredictable systems are dangerous systems. If an AI is doing something erratic or operating at a pace that humans can't follow, oversight breaks down. The rhythmic layer is a safeguard against that.
That's a really different way of thinking about AI safety. Most people think about guardrails as rules, don't do this, block that. But rhythm is more like a tempo.
That's a great way to put it. Rules are static, rhythm is dynamic and relational. It's about the ongoing relationship between the human and the system, not just a one-time constraint.
All right, layer 3, the shared interaction layer. This feels like where the human and AI layers actually meet.
That's exactly what it is. The shared interaction layer is the space where humans and AI systems cooperate, co-create, and co-decide. It's not the human layer alone, and it's not the AI layer alone, it's the interface between them, and it has to be designed deliberately.
And there's a Microsoft research framework that speaks directly to this, right?
Yes, Microsoft Research proposed a layered conceptual framework for human agent systems that integrates interaction, process, and infrastructure. What's notable is that their framework elevates process to a first-class concern, meaning the way humans and AI interact isn't just a side effect of the system, it's a primary design consideration. That's the shared interaction layer in action.
And there's also the iScience research on human-AI interaction in safety-critical network infrastructures, things like railways, power grids, air traffic control.
Right. That study published in iScience in August 2025 involved researchers from Politecnico di Milano, Delft University, Deutsche Bahn, Swiss Federal Railways, and others. They found that the widespread adoption of AI creates conditions for a new and inevitable interaction between humans and AI-based decision systems. The word inevitable is doing a lot of work there. This isn't optional. The shared interaction layer has to be designed because it's going to exist whether you design it or not.
That's a bit of a wake-up call. You're going to have this interaction layer. The question is whether it's intentional or accidental.
Exactly. And accidental interaction layers in safety-critical systems are where disasters happen. The turtle card is saying, be deliberate. Design the space where humans and AI meet.
Okay, layer 4, the genealogical layer. This one I find genuinely fascinating. What does genealogy have to do with AI?
The genealogical layer is about traceability and lineage. It asks, where did this AI decision come from? What data trained it? What values shaped it? Who made the choices that led to this output? It's essentially demanding that AI systems maintain a kind of family tree of their own decision-making.
So it's accountability through ancestry. You can't just say the AI decided. You have to be able to trace back through the lineage of that decision.
That's a really clean way to put it. And this connects directly to what the 2026 International AI Safety Report identifies as a core challenge, technical and institutional challenges around risk management. One of those challenges is that AI systems can produce outputs that are very difficult to trace back to their origins. The genealogical layer is a structural response to that problem.
There's also the work on rhythmic expression rights, RER, from the University of Manchester, which is described as a process-based copyright layer for human AI co-creation. That feels adjacent to the genealogical layer.
Very adjacent. The RER framework is specifically about protecting the structural and rhythmic dimensions of human AI co-creation, essentially asking who contributed what and preserving that record. That's genealogical thinking applied to creative output. The turtle card's genealogical layer extends that logic to all AI outputs, not just creative ones.
And from a security standpoint, there's research showing that many generative AI security risks are structural rather than configurable. So if you can't trace the structure, you can't fix the risk.
That's from the Journal of Cybersecurity and Privacy Research by Vijay Kanabar and Kalinka Kaloyanova, published in February 2026. They found that EU frameworks serve in practice as the highest common technical baseline for transatlantic deployments, which is interesting because the EU's approach is heavily focused on traceability and documentation. That's genealogical thinking at a regulatory level.
So the genealogical layer isn't just a nice to have, it's becoming a regulatory expectation in some of the world's largest markets.
Correct. And that's what makes the turtle card framework feel prescient rather than abstract. These layers map onto real regulatory and technical developments that are already happening.
All right, let's get to the fifth element, the principle of slow, stable progression. And I want to push back on this one a little, because the whole AI industry is built on the idea that faster is better.
That's a fair challenge, and it's worth noting that the bigger is better gospel is actually being questioned right now from within the industry itself. Time magazine reported that leading AI companies are experiencing diminishing returns on scaling their systems. Reports from Reuters and Bloomberg suggested this, and there were doubts at OpenAI about continued advancement after an unreleased model failed to meet expectations in internal testing.
So the industry is hitting a wall on the go fast approach anyway.
In some respects, yes. The co-founders of Andreessen Horowitz noted that increasing computing power is no longer yielding the same intelligence improvements. Now, Anthropic pushed back. A spokesperson said they haven't seen any signs of deviations from scaling laws. So it's genuinely contested. But the turtle card's slow progression principle isn't really about compute, it's about deployment and integration.
Explain that distinction, because I think people conflate those two things.
You can develop AI as fast as you want in a lab. The slow progression principle is about how you roll it out into the world, how you integrate it into human systems, how you give people time to adapt. Professor Mohsen Yahyaei from the University of Queensland argued that a slower pace of AI deployment could allow more time for developing safety measures and regulations, and more time for society to adapt to job displacement and other societal impacts.
And the Smart Dev AI Development Lifecycle Guide makes a similar point, that maintenance and iteration, ongoing updates and monitoring to address model drift are essential phases. You can't just deploy and disappear.
Right. The AI Development Lifecycle Framework emphasizes that deployment and integration require seamless integration into existing systems and continuous monitoring. That's slow, stable progression in practice, not a one-time launch, but an ongoing, deliberate process.
And the Swiss cheese model for AI safety, which is a real thing, published on RRXEVE by researchers at CSIRO in Australia, makes the case that multi-layered guardrails have to operate at various levels of the agent architecture. You can't rush that. The Swiss cheese model is a great reference point here. The idea is that each layer of defense has holes, like slices of Swiss cheese, but if you stack enough layers, nothing gets through. The turtle card's 5 layers work the same way. No single layer is perfect. The human layer has gaps. The rhythmic layer has gaps. But together, they create something much more robust. And slow progression gives you time to actually stack those layers properly, rather than just deploying one and hoping for the best.
Exactly. The turtle doesn't rush. And that's not a weakness, that's the shell.
I want to go back to something you mentioned earlier about the human layer and the Pope's encyclical, because I think there's a tension worth exploring. The encyclical says technology is never neutral. It takes on the characteristics of those who devise, finance, regulate, and use it. But who are those people? And are they the right people to be shaping the human layer?
That's the hardest question in this whole space. The International AI Safety Report 2026 was backed by over 30 countries and international organizations: Australia, Brazil, China, the EU, India, Kenya, Nigeria, and many others. That breadth is deliberate. The human layer can't just represent one culture or one economic system. It has to be genuinely plural.
And yet the people actually building these systems are concentrated in a pretty small number of places and institutions.
That's a real tension. And it's why frameworks like the turtle card matter. They create structural requirements that push back against concentration. The genealogical layer, for instance, forces transparency about who made what decisions. The shared interaction layer demands that the people using the system have genuine agency in it. These aren't just technical specifications, they're power distributing mechanisms.
That's a really interesting reframe. The layers aren't just safety features, they're also governance features.
Precisely. And that's why the turtle card concept resonates beyond just the technical AI safety community. It's speaking to questions of who controls these systems and how accountability is maintained over time.
Let me ask you something that I think a lot of listeners might be wondering. This all sounds very structured and principled. But in practice, AI is moving incredibly fast. Companies are shipping products constantly. Does a framework like this have any real teeth?
That's the right question to ask. And I think the honest answer is, it depends on whether it gets embedded in regulation or just stays as a conceptual framework. The research from Kanabar and Kaloyanova found that EU frameworks are already serving as the highest common technical baseline for transatlantic deployments. So when regulatory frameworks adopt layered thinking, companies have to follow.
So the turtle card's teeth come from regulation, not just from good intentions.
Good intentions are necessary but not sufficient. The International AI Safety Report 2026 is explicit about this. It talks about technical and institutional challenges together. You need both the technical architecture and the institutional enforcement. One without the other doesn't hold.
And the slow progression principle actually helps here too, right? Because if you're moving deliberately, you have time to get the regulation right before the deployment is irreversible.
That's the core argument for it. Professor Yayai's analysis specifically notes that a slower pace could allow for more thorough consideration of ethical issues and more time for regulation to catch up. The problem with moving fast is that by the time you realize something went wrong, it's already embedded in critical infrastructure.
And the iScience research on safety-critical network infrastructures, railways, power grids, makes that very concrete. These are systems where a failure isn't just an inconvenience.
Right. The iScience paper notes that AI demonstrates high potential to contribute to more flexible operations of safety-critical network infrastructures, but the widespread adoption creates conditions for a new and inevitable interaction between humans and AI-based decision systems. Inevitable. So the question isn't whether this interaction happens, it's whether it's designed well.
And the turtle card is essentially a blueprint for designing it well.
That's the ambition. 5 layers, each addressing a different dimension of the human-AI relationship, working together the way the Swiss cheese model's layers work together, not perfectly individually, but robustly as a system.
I want to make sure we've given each layer its due. Let's do a quick recap. Human layer, human values and accountability at the core. AI rhythmic layer, predictable, legible AI behavior that humans can follow. Shared interaction layer, deliberately designed space where humans and AI cooperate. Genealogical layer, traceability of decisions and lineage of outputs. And slow, stable progression, deliberate deployment that gives time for safety, ethics, and adaptation. Does that capture it?
Capture it? That's a solid summary. And what ties them together is the turtle metaphor itself. The shell is the protection, the slow pace is the deliberateness, and the whole organism is integrated. You can't just take one layer and call it safe.
So when you step back from all of this, the 5 layers, the research, the regulatory landscape, what does this really come down to for someone who isn't a researcher or a policymaker? What does this mean for the average person interacting with AI every day?
It means that the AI systems you interact with are either designed with these kinds of layers in mind, or they're not. And you can actually start to notice the difference. Does the system behave predictably? Can you understand why it gave you a particular output? Is there a human you can reach when something goes wrong? Those are the human layer, the rhythmic layer, and the genealogical layer showing up in your daily experience.
That's a really practical lens. You're essentially saying, use these layers as a checklist for evaluating the AI tools in your life.
Exactly. And push back when they're missing. The shared interaction layer only works if the humans in the system actually exercise their agency. If you just accept whatever the AI outputs without question, you've effectively removed yourself from the shared interaction layer.
And the slow progression principle, that's something individuals can advocate for too. Not just accepting that every new AI feature gets rolled out immediately to everyone.
Absolutely. The argument for slow progression isn't anti-innovation, it's pro-resilience. The AI development lifecycle research is clear that maintenance and iteration, ongoing monitoring and updates are essential phases. Slow progression is what makes those phases possible.
Here's what this really comes down to. The turtle card isn't a limitation on AI. It's a design philosophy that says the relationship between humans and AI is too important to be left to chance or speed.
And that philosophy is showing up everywhere right now. In the International AI Safety Report 2026, in EU regulation, in safety critical infrastructure research, in the Pope's encyclical. The convergence is striking. Different institutions, different methods, same conclusion. You need layers and you need time.
The turtle wins the race not because it's fast, but because it doesn't stop, it doesn't crash, and it carries its protection with it the whole way.
That's the whole framework in one sentence.
So the next time you see an AI system deployed overnight with no explanation of how it works, no human accountability, no way to trace its decisions, you'll know exactly what's missing. 5 layers. And a turtle that nobody bothered to listen to.
And the stakes of not listening are only going up. The 2026 AI Safety Report is explicit. Real-world evidence for several risks is growing. This isn't theoretical anymore.
Thanks for walking us through all of this. This has been one of those conversations where a concept that sounds almost whimsical, a turtle card, turns out to be one of the most serious and grounded ideas in the space.
That's the thing about turtles. They've been around for over 200 million years. Maybe there's something to the strategy.
And with that, thanks for joining us on Copilot Podcasts. The shell is the point. Don't let anyone convince you to leave it behind.